The black shoreline appeared first. No color, no waves, no sunlight reflecting from its surface. Only a vast, dark boundary surrounding Titan's northern pole. For decades, frozen worlds had followed familiar rules. Beyond the warmth of the inner solar system, temperatures plunged so low that liquids simply ceased to exist. Ice dominated everything. Rock fractured under impacts. Nothing resembling an open sea was expected to survive. Yet orbit after orbit, the spacecraft returned the same strange image. The dark regions did not resemble craters filled with debris. They did not spread randomly across the landscape. Instead, they traced winding margins that curved and branched like coastlines. Peninsulas reached into darkness. Narrow inlets cut deep into brighter terrain. Entire shorelines wrapped around enclosed basins with shapes that looked unsettlingly familiar. Not because anyone expected oceans. Because coastlines tend to form where something flows. Radar had produced the images. Instead of photographing Titan through its thick orange haze, the spacecraft sent radio waves toward the surface and measured what returned. These northern basins reflected almost nothing. That alone was not enough. Radar measures how rough a surface appears to radio waves. An exceptionally smooth plane can resemble liquid. A frozen sheet, under the right conditions, can also produce a weak signal. The measurement described behavior, not composition. So the simplest explanation remained alive. Perhaps Titan possessed unusually smooth frozen ground. Researchers compared the dark regions with every obvious alternative. Smooth ice. Frozen plains. Geological deposits. None explained the pattern. With every new radar pass, the winding margins continued to behave like coastlines. Nothing had yet proved that liquid existed. Nothing had disproved it either. The shoreline itself became the investigation. Titan was no longer simply another frozen moon. It had become a place where the landscape behaved as though an impossible sea lay waiting beneath an orange sky. The next pass over Titan used a different way of seeing. Radar had outlined the mysterious shoreline. Now the spacecraft searched for something radar alone could never provide. Reflection. If those dark basins were nothing more than unusually smooth frozen plains, sunlight would scatter in many directions. The surface would brighten gently, never concentrating its light into a single point. But if a perfectly smooth liquid surface waited below the haze, there was one precise location where everything would change. Scientists calculated where that reflection should appear before the observation was made. When the spacecraft crossed Titan again, its infrared instrument looked directly toward the predicted position. A brilliant flash answered. For an instant, sunlight struck the surface and returned almost like a mirror. Not across the entire basin. Not as a diffuse glow. As one intensely bright point. Solid ground does not behave that way. A rough surface breaks reflected light into countless directions. Even polished ice cannot produce such a concentrated signal over a landscape of this scale. The observation matched only one physical boundary. A calm, liquid surface. The investigation immediately changed. The infrared reflection alone would have been remarkable. But the researchers were not interested in isolated measurements. They placed the new observation directly over the earlier radar maps. The two datasets aligned. The mirror-like flash fell inside the same dark basin whose winding margins had puzzled scientists since the first radar passes. Two entirely different instruments had arrived at the same destination through completely different methods. One measured reflected radio waves. The other measured reflected sunlight. Neither depended on the other's assumptions. Both pointed toward the same conclusion. The opening shoreline no longer marked an unexplained feature on a frozen moon. It bordered a genuine body of liquid. The first contradiction had been resolved. Liquid could exist on Titan. Only one mystery had disappeared. A larger one immediately replaced it. Nothing about Titan's temperature had changed. The surface remained cold enough to freeze water harder than granite. Yet stable seas still stretched beneath its orange atmosphere. The liquid was real. What that liquid could possibly be remained completely unknown. The seas no longer needed to be proven. Now they had to be explained. A world can preserve liquid for a very long time without having weather. Hidden groundwater on Earth can remain isolated for thousands of years. Ancient lakes can survive long after the climate that created them has disappeared. Titan's newly confirmed seas could have been the same. Cold, still, disconnected from the sky above them. The only way to test that idea was to stop looking at the surface. Instead, the investigation turned upward. As the Huygens probe descended through Titan's atmosphere, it sampled the air continuously. Pressure changed, temperature changed. Most importantly, the composition of the atmosphere changed with altitude. If the seas were isolated reservoirs, the methane mixed into the atmosphere should remain relatively uniform from top to bottom. It did not. The closer the probe came to the surface, the more methane it measured. Humidity climbed steadily. Near the ground, the air approached saturation. That pattern was difficult to ignore. An atmosphere does not become increasingly saturated with methane beside an inactive surface. Something below was feeding it. But one measurement could still leave room for doubt. Perhaps the atmosphere had been shaped long ago, preserving methane without any modern exchange. Another line of evidence refused to fit that explanation. From orbit, the spacecraft repeatedly watched bright cloud systems appear through Titan's orange haze. They were not permanent. They formed. They drifted. They disappeared. Season after season, new cloud decks emerged in different regions before fading again. Static seas cannot create moving weather. Clouds require vapor. Vapor requires continuous exchange between the surface and the atmosphere. 3 independent observations now pointed toward the same reality. The descending probe measured methane increasing toward the ground. Its atmospheric instruments showed conditions approaching saturation. Orbital observations recorded methane clouds forming and vanishing across Titan's skies. Together, they overturned the simplest explanation. Those dark seas were not merely surviving in the cold. They were breathing with the atmosphere. The shoreline returned once again. Nothing about its shape had changed, but it was no longer simply the edge of a liquid sea. It had become the boundary where Titan's atmosphere and surface exchanged the same material, completing the first unmistakable evidence that this distant moon possessed not only liquid, but weather. The atmosphere was no longer an isolated mystery. If methane could evaporate into the sky, gather into clouds, and return again, one question became unavoidable. Could that weather change the land beneath it? The simplest answer still seemed to be no. Titan's surface was built from water ice frozen so solid that, at these temperatures, it behaved like bedrock. Even with occasional methane rain, it seemed reasonable to imagine a landscape that remained largely untouched. Then Huygens descended below the orange haze. For most of the journey, Titan revealed almost nothing. The thick atmosphere hid the surface behind a uniform amber veil. Then, as the probe fell lower, the haze began to thin. A landscape slowly emerged. Bright highlands stretched across the horizon. Dark lines threaded through them. At first, they appeared random, almost like cracks spreading across frozen ground. As the images sharpened, that explanation became harder to defend. The dark lines divided into smaller branches. Those branches divided again. Short tributaries merged into larger channels that all descended toward darker, flatter lowlands. The pattern was unmistakable. It matched the geometry of drainage basins carved by flowing liquid. Researchers tested every obvious alternative. Tectonic fractures usually cut through terrain in long, continuous breaks. These channels did not. Ancient lava flows spread outward from volcanic sources. These features repeatedly merged downhill. Impact damage leaves chaotic scars. These valleys formed organized branching networks. Each competing explanation failed for the same reason. The landscape behaved as though liquid had repeatedly flowed across it. The probe kept descending. Only after it reached the surface did the next piece of evidence appear. Its cameras revealed a plain scattered with rounded blocks of water ice. Not sharp fragments. Not freshly broken slabs. Rounded cobbles. On Earth, stones acquire shapes like these after countless collisions while being carried by rivers. Their edges slowly disappear as moving water rolls them against one another. Here, water could not have done that. Water was the rock itself. The only liquid capable of transporting those icy blocks was the same substance already verified in Titan's seas and atmosphere. The investigation changed once more. Methane weather was no longer confined to the sky. It had left its signature on the ground. The branching valleys led downhill toward the dark basins first mapped from orbit. The rounded cobbles testified that flowing liquid had transported material across the frozen landscape. The shoreline returned again. It was no longer simply where a sea met the land. It had become the destination of an entire drainage system. Every river valley now pointed toward it, carrying the evidence that Titan's weather did not merely exist. It built the world beneath it. The rivers, the clouds, and the seas now pointed in the same direction. But they could still have been local phenomena. A single region can experience unusual weather without representing an entire planetary climate. One river network does not prove global circulation. One sea does not reveal how a world behaves over time. Only patience could answer that question. The spacecraft did not leave after one flyby. For more than a decade, it returned to Titan again and again, watching the same coastlines through changing seasons. If the lakes were isolated reservoirs, their boundaries should remain largely unchanged. Instead, the shorelines refused to stay still. Some margins advanced. Others retreated. The changes unfolded slowly across years, matching the rhythm of Titan's long journey around the sun. This was not weather measured in weeks or months. One season on Titan spans many Earth years. Time itself had become another instrument. As the shoreline shifted, the atmosphere changed with it. Methane cloud systems appeared in new regions, then faded as the seasons progressed. Their migration was not random. It followed the same long seasonal cycle the changing lake margins appeared to record. The atmosphere and the surface were no longer telling separate stories. They were describing the same process from different directions. Another clue emerged around several retreating lakes. Where liquid had once covered the ground, bright rings began to appear along the exposed margins. These were not fresh deposits washed in from elsewhere. Infrared observations identified them as evaporite materials, chemical residues left behind after the liquid itself had disappeared. The shoreline had preserved a record. It showed where liquid had once stood. It showed that the lakes did not simply exist. They filled. They receded. They left evidence behind. No single observation could have established a planetary climate. But together they formed a pattern that repeated across years of independent measurements. Radar tracked changing coastlines. Infrared observations followed migrating clouds. Surface chemistry recorded the aftermath of evaporation. Each new data set reinforced the others without depending on them. The shoreline returned once more. At the beginning of the investigation, it had been nothing more than an unexplained boundary surrounding a dark basin. Now it carried the history of changing seasons. Its position marked where liquid had risen. Its bright margins marked where liquid had fallen. It had become a record written directly into Titan's landscape, preserving the evidence that rivers, clouds, lakes, and atmosphere were evolving together across an entire world. Years of observations now lay on the table. Liquid seas, an atmosphere rich in methane, transient cloud systems, river valleys carved into frozen water ice, rounded cobbles transported across the surface, shorelines that advanced and retreated with the seasons. Each discovery had been verified independently. Each had answered a different question. One final question remained. Were these simply remarkable coincidences? Or had every investigation been examining different parts of the same machine? Taken separately, each observation demanded its own explanation. The seas required one story. The clouds, another. The rivers, a third. The changing shorelines, yet another. But every additional explanation made the picture more complicated. A simpler reconstruction slowly emerged. The liquid gathered in the northern seas. From there, methane entered the atmosphere. As conditions changed, that methane condensed into clouds suspended beneath Titan's orange haze. When the atmosphere could no longer hold it, methane returned to the surface as rain. Not as constant drizzle, as rare but powerful downpours separated by long seasonal intervals. The rainfall rushed across slopes of rock-hard water ice. It carved branching valleys. It carried rounded blocks of ice downhill. Those channels emptied into the same liquid basins first discovered by radar. Over the years, the shorelines shifted as methane evaporated, condensed, fell again, and slowly redistributed itself across Titan's surface. Nothing remained isolated. Every verified observation occupied a natural place within the same circulation. No additional mechanism was required. The investigation that had begun with one unexplained shoreline had quietly reconstructed an entire planetary climate. The shoreline appeared again. Its shape had not changed. The viewer had... At first, it seemed to mark the edge of an impossible sea. Later, it became proof that liquid truly existed. Then it became the place where atmosphere and surface exchanged methane. After that, it became the destination of rivers. Now it revealed all of those meanings at once. It was the source of evaporation, the receiving edge of drainage systems, the record of changing seasons, the visible boundary of a complete methane weather cycle, the hidden system had finally become visible. Every measurement from the spacecraft and the descending probe now pointed toward the same conclusion. Titan was not a frozen moon interrupted by scattered curiosities. It was a functioning world whose atmosphere, rainfall, rivers, lakes, and seasons operated together as one self-renewing methane climate. The investigation began with a mistake. Not a mistake in the measurements. A mistake in expectation. At first glance, Titan seemed to challenge the rules that had shaped every familiar landscape on Earth. Seas lay beneath an open sky where temperatures hovered near minus 180 degrees Celsius. Clouds drifted overhead. Rivers crossed the surface. Shorelines shifted with the seasons. It was tempting to think the moon behaved like Earth because it had somehow become another Earth. The evidence pointed somewhere else. On our planet, water changes between ice, liquid, and vapor under Earth's temperatures and pressure. Those changes power evaporation, clouds, rain, rivers, and oceans. Titan follows the same physical choreography. Only the substance is different. Its surface conditions allow methane, mixed with ethane and dissolved nitrogen, to move through those same transitions. Liquid becomes vapor. Vapor condenses into clouds. Rain falls. Rivers carry the liquid back toward the seas. Seasons redistribute it across the moon. The chemistry changes. The physics does not. That is why Titan's landscape feels strangely familiar without ever becoming recognizable. Replace methane with water, and Titan's climate disappears. Replace Earth's water with methane, and our own weather would disappear as well. The resemblance between the two worlds is not built from the same material. It is built from the same physical laws acting under different conditions. The shoreline returned one final time. It was the same dark boundary that first appeared as an unexplained mark on a radar map. Nothing about its outline had changed. What changed was every piece of evidence gathered around it. It was now the place where rivers arrived after rare methane storms. The place where liquid slowly returned to the atmosphere. The place where changing seasons left visible traces along retreating shores. The visible edge of a complete climate system assembled from years of independent observations. One shoreline, one world. One investigation completed. Questions remain about how Titan replenishes its methane over geological time. Researchers continue to investigate whether hidden internal sources contribute to that long-term balance. But those uncertainties do not alter what the observations have already established. The dark shoreline surrounding Titan's northern seas is no longer an impossible feature on a frozen moon. It is documented evidence that an entire weather system can emerge from chemistry utterly unlike Earth's, while remaining faithful to the same universal laws of physics.